So first off, I just want to thank NRCan for inviting me this opportunity to speak to you all about flexibility markets. So just as general introductions, my name is Patrick Lowe. I am the Senior Manager of Partnerships and Innovation Research and Development. And what that means is I actually have every year $9.5 million to invest in new and innovative technologies to address electricity affordability and reliability. And so happens one of the great projects that I've been leading is Canada's very first local electricity market, or flexibility market, if you will. So the presentation I'm about to do provides you a bit of an oversight of what this project is and some of the very valuable lessons coming out of the execution. So with that said, let me start presenting. So we officially called this particular project IESO's York Region Non-Wires Alternatives Demonstration Project. And the area of focus in Canada is a place called York Region itself. And so, as I mentioned before, it is Canada's very first local electricity market. And the way it's been funded, it's $5 million from the Grid Innovation Fund, which is a portfolio that I manage, and as well $5 million from NRCan. So NRCan has been very generous in helping us out with this particular undertaking. We are working with a local utility, Electra, to deliver this particular project. And if you want to learn more, there's a web link there, www.yrdemo.com. And one of the things we're going to talk about further on is interoperability. And in this particular project, we are going to be piloting a total DSO, DSO standing for Distribution System Operator, interoperability framework. And as I mentioned before, we are focused on a particular area called York Region. And just to give you an idea of the growth that that occurred there, there's a peak demand about 1,350 megawatts, which essentially is 1/3 of a nuclear power plant, all within this one particular region. So an area of tremendous growth. And this really gives us an opportunity. Can we use a local electricity market or a flexibility market to defer capital investment needs? So let's just get into the interoperability piece. This is one of the most fascinating topics I find right now when we're talking about flexibility markets is how do we interact from a transmission system level, so at a wholesale level, all the way down to a particular DER device. And right now, when we think about markets, right across the board, there's different ISOs running different markets. But one of the biggest challenges right now in terms of DER is the minimum size threshold required for these resources to play in markets. So in Ontario today, you need to have at least 1 megawatt or more of aggregated DERs to participate in any of IESO's wholesale markets or any of ISO's administrated markets itself. And in the future, if we want to allow more DERs to participate, we're going to have to change these models around. And we published a white paper focused on T&D interoperability earlier this year, and we really identified that there's 3 potential models that we can use to allow more DERs to participate in these administered markets. Now, the first one is a total TSO model, and by TSO, it stands for Transmission System Operator. And what that is DERs can directly participate in the transmission system level market itself. And what that means is we'll have to either lower the minimum size threshold or find new ways for aggregation. And this is something right now, especially with FERC 2222, this is something a lot of ISOs right now in North America, they're starting to look at as well is what are all the different partition models and how can we get DERs to participate directly into wholesale markets? Now, the second type of model is hybrid DSO, and DSO being distribution system operator. And what if one particular asset can participate simultaneously in both the wholesale market and also the distribution system level market? And so it's an interesting concept where if we build this local flexibility market, the DERs can provide support or capacity for one distribution level local area. But at the same time, it'll need some robust coordination if this DER asset can also provide services in the wholesale market. And this becomes extremely complicated just to make sure that the management of this DR, there's a strict coordination between the TSO to DSO to ensure that the same capacity is not double counted in both markets. Be like just even intelligent dispatching to this particular DR to make sure that all the capacity available is not rendered into only one market and won't be available for the other one. So there's a lot of complexity with the hybrid DSO. The final one that I'll be talking or focusing a little bit more on is a total DSO, total distribution system operator model. And what that means is there's a transmission system level market, and this is run by the ISOs. And then the second is a distribution system level market. And this is something that is local needs. So very much local distribution companies can start enabling some of these more local flexibility markets. And finally, the DER. And in theory, what happens is the DSO, they will procure DERs for services at the distribution system level. And then in return, they'll aggregate all these DERs and then bid it up into the transmission system level. And if you really want to look at the DSO as a super aggregator, an aggregator of aggregated DERs, that's essentially what it is. So this kind of explores three different models of interoperability that we could be potentially looking at. But for the purpose of the ISO's York Region Demonstration Project, the focus is on the total DSO model. And so this is just an illustration of the local opportunity and what we're going to be using DERs for. And so historically before, anytime there's a lot of tremendous load growth, what would you do? You'll either have to install new generation and then pull new transmission lines and distribution lines to basically transport this new generation to the new load. But here we're really exploring, hey, but what if we site DERs right where the new load growth is? Can we actually defer capital investments? Can we defer the poles and wires? And that's essentially what we're looking at here for this ISO's York Region Non-Wireless Alternatives Demonstration Project. Can we procure local solutions to meet local needs? And so what are the key demonstration objectives? Well, the first one is community engagement. This is the first time we're actually working with the communities right at their level to really procure local solutions to meet local needs. We hear a lot about the climate change. A lot of communities are starting to move towards more community-based renewable planning. And what we really want to do is let's build a market to also support some of these newer, greener technologies that these communities will be procuring and give them a new stream to capitalize on a lot of these assets. We're also going to be exploring market-based constructs to procure DERs. Whereas historically, a lot of distributed energy resources in the form of generation, solar and wind, they were procured by government incentives. And this time around, we're actually going to see, can we create a competitive market to procure these instead? Interoperability. So one of the most important pieces, how do we explore coordination between the ISO, the wholesale level market, and an independent distribution system operator? And interoperability comes in two streams. One is all the communications. So the way I view it is SCADA, right? SCADA technologies, which stands for supervisor control and data acquisition. But the second piece we're going to be testing interoperability is actually through market constructs, i.e. price signals, and what interoperability looks like there. The next one is operations. And so every DER will behave differently. And whether it's a demand response or energy storage or some type of generation resource, they'll all behave differently. And this really gives us an opportunity to see what their operating characteristics are in a market format. And finally, validation. Let's prove that, you know, can we actually use DERs? Are they cost competitive as opposed to procuring or as opposed to basically building new poles and wires? And so just some high-level overview of the demonstration mechanics for this local flexibility market. We are allowing for direct participation of DERs along with aggregation. And the DR capacity we're allowing is between 100 kilowatts to 3 megawatts. And once again, this allows for aggregation as well. And this is really interesting because previously before in ISO administered markets, the minimum size threshold is 1 megawatt, which was really a barrier to entry for a lot of these potential resources. But now the fact that it's 100 kilowatts, we can actually procure some new diverse resources such as aggregated smart thermostats, for instance. So we're pretty excited to see what actually comes and what will bid into our auction. Permitted resources include demand response, gas-fired, and storage resources. And we are going to be holding our very first local capacity auction November 18th to 19th with a target capacity of 10 megawatts in year one. And with a commitment period, what that means is these resources will need to be available and dispatched during May to October of next year in our summer commitment period. So by the time I'm recording this now, but by the time we come and speak in person, this auction would have already cleared. So I can probably share a lot more information on exactly what resources clear and go through some of the semantics of our post-auction report. And so one of the most interesting things too is we're also holding a local energy auction as well in conjunction with the local capacity auction. And what we're looking at is something called distribution locational marginal pricing, DLMP, used to settle activations. And I can talk for days and days about DLMP. I probably won't, but it's a mechanism that's been explored a lot in papers, and we're actually going to try it out in this particular pilot. And just to give you an overview of demonstration timelines, we've actually cleared a lot of these. And the most exciting one will be 18th to 19th when we actually hold our local capacity auction. And from registration, we know this is going to be a pretty competitive auction. So more to come on this one. And so for the past year, I've been leading a team and working with Electra, the local utility, to really deliver on this project. And believe me, there's been a lot of lessons. So one of the things that we learned is there's a significant difference in roles between distribution planning, distribution network operations, and even a distribution system operator. And I know sometimes out in industry, people view distribution system operations and distribution network operations interchangeable. Believe me, it is not. And I'll dive more into it in this presentation. As well, we'll also look at the importance of community and sector engagement, i.e., because we're running a competitive auction right now down to such a minimum size threshold of 100 kilowatts, we really need to go out there and engage the communities and all the industrial customers that might have these DER resources and really give them the value stream. Talk to them at a level that they'll understand. Take a focus on a community lens, for instance, or a business owner's lens, as opposed to our traditional ways of talking either via, utility or talking like a market operator. We needed to identify how exactly to engage customers to participate in such a market. We also needed diverse subject matter expertise in order to create this distribution level flexibility market. And the most important thing that we learned is regulatory challenges are actually way more difficult than technical challenges. So I'll dive down into this a little bit further. So as I mentioned before, there is a significant difference in roles between distribution planning, a distribution network operator, and a distribution system operator. And if you want to view distribution planning as essentially, planning, this is the role that a lot of local distribution companies, utilities, or distributors, this is the role that they really undertake. And what they do is they do scenario-based probabilistic distribution planning, i.e. they take a look at the entire system and they try to forecast upcoming demand within their jurisdiction. They also plan all the assets that need to be installed to maintain reliability. And they look at DER interconnection, i.e. when you connect new DERs in the system, you have to still maintain reliability and make sure the system is not impacted adversely. They also are responsible for DER hosting capacity. So every feeder, there's thermal limits. There's also capacity limits based on the transformer upstream. So they have to actually do a lot of these analysis just to understand what what hosting capacity feeder can take for additional DERs. They also look at a DER locational value analysis, and that's more if they're going to be using DERs as part of their own distribution planning to meet or satisfy needs. And they also undertake integrated transmission distribution planning. Now, from the operating side, and this is from the distribution network operator lens, they need to design, build, and operate the distribution grid. And they're also responsible for switching, outage restoration, distribution maintenance. And operations becomes its own unique art form, especially down to the distribution level, where every outage, every fault condition, these all have to be accounted for when managing such a system. Physical coordination of DER schedules, which means just because DER is there doesn't mean that you can dispatch them. And anytime they need to take an outage on a feeder to do any maintenance work, or anytime there's a fault on the system itself, this is where the distribution network operator will send signals down to the DERs. Either they need to come offline or they need to relook at dispatching schedules. And this is where also real-time coordination at the ISO between the T&D interface can occur. So this is actually, now I'm going to talk about the distribution system operator from a market context. And this is what's fairly new and not very predominant. So what a distribution system operator will do is source distribution level grid services. They'll also optimize dispatch of DERs to provide distribution grid level services too. So they'll figure out what time is best to send these signals down to these DERs so they can come online. They also aggregate DERs for the wholesale market participation. So once they procure a lot of DERs, they'll add them all together and then they can bid into the wholesale market. They also operate distribution level energy markets, and they'll actually facilitate transactions amongst the DERs. They'll clear and settle DER transactions, so they have a lot of tools available. They'll need to figure out measurement and verification, for instance, and that could come through smart meters or exploring how distribution level telemetry from smart inverters, for instance, can help clear and settle markets. And they actually do general overall market facilitation. So as you can see here, there's actually three very distinct roles. Now, the first two, distribution planning and distribution network operations, they are historically bundled together, and these roles are undertaken by local utilities or local distribution companies. And it's really the market operator, this distribution system operator, that's very new and unique moving forward. So the other thing we really learned is it's really important that we had community and sector engagement. And we actually had to go to the community of York region, and we talked to the local governments there. We talked to the local communities, all the different industrial players, anybody that actually potentially has any resource to participate, to come on board. And so once the auction clears, we'll be able to talk a little bit more about all the different unique, diverse type of customers that participated in our market. And finally, as well, we really were able to unlock new distribution energy resource. And just from the fact that we can talk to different wide classes of asset owners. And that's where I mentioned before too, that we might see smart thermostats now participating as a DER in these local flexibility markets, which will be really interesting. And at the end of the day, when the auction clears, we'll see which assets we can explore a little bit more. So to undertake a local flexibility market as well, to build one, we needed really diverse subject matter expertise. And that's where we needed market operations. And that's where IESO, the team I led, brought this to the table. We also need to understand distribution planning and network operations. And so Electra, we had to coordinate with Electra on ensuring that any type of market that we create does not adversely impact the distribution system. We required a lot of regulatory expertise. As I mentioned before, regulatory hurdles were some of the biggest challenges, which we'll talk about a little bit further. We also needed really strong legal subject matter expertise. And once we come up with a design on what this market should look like, we needed to put it down on paper. And this is where I understand legal and the huge significant undertaking legal needed to play. And through every single word, every single sentence, everything that they put together in paragraph form, this would really bind together our entire market design and ensure that the legalities of it when we take it out to market. We also needed stakeholder engagement, and that's where we went out and talked to all the communities. And finally, good old strong fashion marketing. Just because we built a market didn't necessarily mean that people would come to it. So now shifting to regulatory considerations, some of the things that if there are any distribution companies thinking about building local flexibility markets, the first and foremost is a revenue pool needs to be established to settle DER participants. And because through this project, it's coming through research money and grant money, it was fairly easy for us to establish this revenue pool. But moving forward, if someone like a local utility wants to establish a revenue pool, what does this look like? Like, can they take ratepayer dollars to establish this revenue pool? Would regulators allow for something like this? Or does this have to come through revenue or profits from a utility itself? So this is a big question mark that we still need to kind of identify. Retail settlement code. So a lot of utilities are bound by retail settlement codes, and whether or not the codes allow for such a market to take place, that's something that has to be explored as well. Can utilities can they pay capacity availability payments in return for services rendered too? So can they treat it like a traditional procurement for DER resources, or is this something that needs to be reconsidered at the regulatory level? As well, can utilities pay distribution location marginal pricing versus traditional hourly energy price? And in Ontario, we also have securities laws. So, and then this is more for the wholesale market transaction piece. So with that, it's been a fantastic year undertaking this flexibility market. A lot more to come, and by the time I actually am able to chat with you, well, I won't say in person, but virtually, hopefully we'll have a lot more learnings that I can share. So with that said, thank you very much, and thank you once again to NRCan.